Hello everybody. Welcome to the fourth video of AlgebraCloud, and in this video we're going to cover division properties of exponents. It's kind of similar to the multiplication properties, but it's kind of like added more stuff. But let's just get into it. There's three primary rules underneath division properties of exponents, and one will be the quotient of powers, which is similar to the product of powers in just a moment. Yeah, the product of powers in the third video. We have the positive power of quotient, and whenever we have a fraction involved in the base raised to an exponent, and we have a negative power of a quotient where we have a fraction involved in the base and there is a negative exponent. Now each one of these we're going to go through in each case, and I'll start pointing out where they are. Now in quotient of powers we have two different terms that share the same base but have different exponents and are divided over each other. And simply we just need to take on the same base and subtract the exponents from each other. So in our first example we have 7/3. No, in case 1 we had to simplify 7/3 over 7 to the power of 2. So we have the base 7, exponent is 3, minus 2, we equal 7 to the 1. And that's pretty much it for the quotient of powers rule. It's not that hard. What might be difficult is whenever there's more terms involved, and just make sure you can't divide amongst different bases. And like in our second problem, in case 1, then we have x to the 7th times y to the 3rd over x squared and times y to the 1. And this one we have two bases, which is x and y, and naturally you just can't do this. You can't divide y thirds over y to the 3rd over x squared. They don't share the same basis, so it wouldn't work out according to one of our rules. So we have the only thing that will work will be the x to the 7th and x squared together. So let's just work with these. So we have x 7 minus 2 times, and then we have the y's also, which will be y thirds minus 1, and which will be x to the 5th times y to the 2nd. This process doesn't seem that particularly hard. Whenever you have multiple terms involved, then that's when it might get a little bit messy. Just always try and simplify and try and reduce whatever you can, or whatever you already see, to make it easier on yourself. Now, in case 2, you're given sometimes scientific notations that you're supposed to divide by them, by another scientific notation. And a simple way of just setting this up is that you're giving a number above 1 but less than 10 in front of each one, and you pretty much just do whatever it tells you. You're just telling us to divide. So 3.5 times 10 to the power of 4 divided by 2.5 times 10 to the negative 2. So we could just set it up 3.5 times 10 to the 4th power divided by 2.5 times 10 to the negative 2, which would equal 3.5 over 2.5 times 10. And you notice here the 10s share the same base, but they have a different exponent. So you would do y4 minus negative 2, which is a positive, where you're pretty much just adding a 2. So it will come out to be 3.5 divided by 2.5 times 10 to the 6th power. Now 3.5, let me just check. Let's see. 3.5 divided by 2.5 is equal to 1.4 times 10 to the 6th power. And that's pretty much what we're asked to look for. It can actually be worded in a way that it's asking 4. Let's see how it looks like. Just a moment. Okay, so it's asking you can simplify each quotient, and then you should write it in scientific notation naturally. So it's pretty much what we're looking for here. You're just applying the rule, the quotient rule. Let's try another one. So we have 2.0. I'll just add a 0 in there. 2.0 times 10 to the power of 4 divided by 1.5 times 10 to the power of 6, 10 to the power of negative 6. So we have 2.0 divided by 1.5 times 10 to the power of 4 times 10 to the power of negative 6. And right here we have 2 divided by 1.5 times 10 4 minus negative 6, which would equal, and right here we have 2 divided by 1.5, which is, my calculator tells me it's 1.3 repeating, but it looks like it could be 4/3 to me. Okay, so, but we'll just keep it at that. Okay, times 10 to the 4 plus 6. So don't forget, whenever you're subtracting a negative number, it turns into positive. So our final answer will 1.3 repeating times 10 to the 10. And that will be our answer in scientific notation. Hopefully everybody can see that. Okay, so continuing on. In the next part, we have, let me just move the camera. Okay, so in the next part, we have positive powers of a quotient, negative powers of a quotient. Now, for positive powers of a quotient, all you would need to do is whenever you have a fraction inside the base, or multiple terms inside the base, you have the exponent here, m, the outside one, and you would just need to distribute to every single term that's inside the base. So right here you have a and b, a over b, and parentheses raised to the power of m. So that m will distribute to every single term inside. So am over bm. Now let's just try that. And right here in case 1 we have 4 over 5 parentheses to the power of 2. So all we need to do is just distribute. Right there. Now you can, and right here we're just asked to simplify. It can be left in this form, or if you're asked for it, 16 over 25. And that will be it. Let's continue on the second problem for problem 2. In case 1, it's pretty much just straightforward. You just need to, since you see multiple terms in here, you have m and a already inside. There's different ways you can approach this, and if you notice right here we have a1 and a5. You can already apply the quotient rule just to this part, but I guess we'll just take the, I'll just show you the other step. So you just distribute m2 times 3, a1 times 1, no, a1 times 3 over a5 times 3, which will equal m to the 6, a to the 3rd, and a to the 15. And right here we're able to apply the quotient rule, and from there on we could just use times a3 minus 15, which would reduce down to minus, what was that, 12? Remember, we don't like negative exponents, so we just bring it down to the denominator. So we have m to the power 6 in the numerator, and a to the power 12 in the denominator, and this will be our simplified form. Usually you're asked to simplify these. Just simplify these, and That's pretty much it. It's kind of tedious. You just have to distribute to every single term and their exponent whenever you have an exponent outside of the parentheses, when you have multiple terms inside the base. In case 2, we're using the, excuse me, let's adjust the camera. Okay, so in case 2, we're using the negative power of a quotient, and what you're pretty much just doing right here, we have an example of a over b to the power of negative n. You would just need to flip the exponent, whatever's inside. Flip the fraction what's inside, so it will turn into b over a, and then your exponent would turn that to a positive. And from then on, you can just distribute like you did in the positive powers of a quotient. So we bn over an. Okay, so let's just try it out. And negative b negative 3 over x squared parentheses negative 2. Now, what you can try and do is that you're usually just naturally taught to move this negative exponent to the bottom in the denominator, but you could just it would still result in the same answer if you were to bring it down there, but it seems like an extra step that we need to do. So I would just flip the fraction, negative 2, and then you would distribute to each exponent. And from there it will be x minus 4 and b positive 6. And so from here we're able to bring down our x to the power of negative 4 down here. And remember, there is a 1 remaining in the numerator. Okay, and that's going to be our final answer for that one, our simplified form. I added another problem that we should do, so you have another way of seeing what we're doing, or how you should approach this. Now, if you notice, inside the base, you have x squared w to the power of 4 over x to the negative 2 and times a. You can apply the quotient rule over here inside the base, and you can already tell that it will be x2 minus a negative 2, which will result in a x to the positive 4, and it will be on top for the numerator. But I'll just show you the distributive way. You can try that way too, but I'm gonna show you this other way. So you have you have this base, and you multiply your negative exponent across. Wait, actually, my bad. You just gotta flip it. Negative 3, and then you would just need to distribute. And so you have x negative 2 times negative 3 times a1 times negative 3 over x squared times negative 3 w4 times negative 3, which would equal, right here, x negative 2 times a negative 3 equals positive 6 times a1 times negative 3, so it'll be a negative 3. And then right here we have a x to the power 2 times a negative 3, so it'll be negative 6. And then right here we have a w4 times a negative 3, so it'll be a negative 12. And right here, you can already tell that we're going to start moving terms around. And let's just move the numerator first. And we have a to the negative 3, so you're going to move it down to the denominator, in which we have x to the 6, x minus 6, w minus 12, and a to the positive 3. Now, if you're already comfortable with moving these negative exponents around, then You can attempt to try to move them, move multiple at the same time. I'm just doing this just to show you the steps. So you can just move right here. You have x minus 6, w to the minus 12, and you already know that these two terms will move up to the numerator. So it'll be x to the 6 times x to the 6th, and you'll have w to the 12th over a to the 3. Now, we're not finished yet because there's two bases here, and the only way to have a simplified form is only if you have one base existing inside the simplified form. So you have x6 times x6, and that should be easy, and which is you have x plus 6 according to the product of powers rule in the third video. So you have times 12 over a to the third. Now just move that over here. So x to the power of 6 plus 6 equals x12 times w12 over a to the 3. And that's our simplified form. Now, I guess that's pretty much it. I'll see you in the next video, and good luck.